Algebra 2, 6.6, finding rational zeros. Today, guys, we are going to use...
Does that say P over Q?
That's P over Q. The rational zero theorem. What we're going to do is we are going to be given polynomials, and we have to find all of the zeros, aka all the factors as well. They're not going to start you with one. So in the last group of problems, we gave you one of them, find the rest of them. Now, we are just going to be given, here's a polynomial, go for it, find them all. Which takes time. So, technically, if I give you a polynomial, you could put any value, any real number you want into it to check. And you'd have to use synthetic division over and over and over and over until you came across one that works. Well, someone figured it out, and they called it the rational zero theorem here. I'll put a line underneath this. They said that if you're given a polynomial, and it's in the form, standard form, where a sub n is your leading coefficient, n is the degree, all the way down to a sub 1x plus a sub o, your constant. If it's in standard form, then it has integer coefficients, then every rational zero of f has the following form. That means your zeros will be in one of those terms from this little formula, let's say, or this list. Basically, we're going to take a polynomial that you could possibly put anything you want into it, and we're going to find a list of potential zeros. Not all of them are going to work, but we're going to find a potential list that is going to take it from an infinite amount of choices down to a set 5, 10, 15, 20 choices. Now, if you're saying, hey, 20 choices, that's a lot to check using synthetic division. It is, but it's a lot better than checking numbers that will never work. So this is all about forming a list of possibilities. And that list of possibilities is P's and Q's. So sometimes I like to say, hey, mind your P's and Q's. In math, it means make your list. And that list, the P is the factors of the constant term, a sub 0, the last number, over the factors of your leading coefficient, a sub n. When I say factors, I means all of the factor pairs, but all the factorizations. So if the number was, say, 6, right? There'd be 1, 2, 3, and 6. Because 1 and 6 makes 6, 2 and 3 makes 6. You got to list them all together. Okay, so it's kind of like playing factor pairs. But those are the factors. So let's do a problem. Our first problem says find all zeros. And this is what they do. That's it. That's all they give you. Now remember from the last section that the degree of the polynomial tells you how many zeros there should be. The degree of this polynomial is what? 3. So there should be 3 zeros. We're looking for 3 answers. So to start this off, I need to mind my P's and Q's. I don't want to put 1,000 here. We could check 1,000. We could use synthetic division, put 1,000 in. I'm going to tell you 1,000's not going to work. So why choose it? Well, how do I know that's not going to work? It's because I'm making a list. Okay? We're making a list. We're checking it twice. Got to find out what's going to work and what's not going to work. So our list says that I need to do the factors of negative 12 over the factors of 1. Where did I get negative 12 from? Negative 12 is your constant. 1 is your leading coefficient. So it's not 12 divided by 1, it's the factors of. That's what I want to list there. And the thing is that these factors are always plus and minus. So what I'm going to do is I'm going to put plus or minus so I don't have to write plus or minus in front of everything. Put a big bracket or a big parentheses. And I'm going to start listing. What are the factors of 12? 1 and 12, yes? 2 and 6. 3 and 4. Would you guys agree that those are all the factors of 12? Those are all numbers that will go into 12? And what are the factors of 1? 1 and 1. You don't have to repeat a number, so it's just 1. We are really close to making our list of possibilities. The one last step you need to do then is divide them. Divide every number in the numerator by every number in the denominator. In this case, there's only one number on the bottom, and it happens to be a 1. A number divided by 1 is that number. How many numbers are there? 1, 2, 3, 4, 5, 6. There are 6 plus ones and 6 negative ones. That means there are 12 potential answers that we have to check for our 3 solutions. 12 possibilities is a lot better than checking an infinite amount. Am I going to check 5? Is 5 a potential solution? No, it's not part of my list. 9's not either. So, you now take in this list, okay, so now I'm going to use synthetic division. To make sure I have a 0 or to find my factors, I want the end result, remember over here, to be a 0. What are my coefficients that go across the top? Do I need a placeholder for this polynomial? Do I have anything missing? Nothing's missing. So it's 1, 2, negative 11, and negative 12. So now I have to make it work. I have to somehow find it to be 0 at the end. I'm going to take out this thing here. We'll make sure that happens. But what number do you guys want to try? 4? Okay. Drop the 1 down. 1 times 4? 4 plus 2? 6. 4 times 6? 24. 24 minus 11, because it's negative 11 plus 24. 13. And 13 times 4? 52. Is that going to add up to 0, guys? Not this time. So guess what? Nope. 4 is not the answer. Took it out. How about we try something like 2? Which is 2, right? 2 times 2, or 2 plus 2 I meant. 4. 4 times 2, 8. That'd be a negative 3. I don't think that's going to give me 0 either, is it? No, so 2 is not an answer. There's a lot of trial and error here, but it's a lot better than trying ones that won't possibly work. You know what? We skipped over 1. Let's just try 1. 1 times 1? 1. 3. What is this? Be a negative 8. That won't work either, will it? You guys seen that? That won't work? Oh, jeez. Can we try negative 1? Let's try negative 1. We haven't tried any negatives yet. What's 1 times negative 1? Negative 1. Then it becomes 1 again, right? Which is negative 1. Negative 11 plus negative 1? Negative 12. What's negative 12 times negative 1? 12. Which will make a 0. We found 1. Negative 1 is a 0. We now need to find 2 more. And hey, wait a minute. What we talked about last time was the fact that when you get down to a quadratic, which is now left over here, bring it back to a polynomial and factor it old school, right? Don't I just want to change this to x squared plus x minus 12? Can I factor that? It'd be a lot easier to factor this. X and x. What are the factors of 12? They'll give me a 1. 3 and 4. The middle number's positive, but the end's negative. So that means one's positive, one's negative.
4 is positive, 3 is negative.
4 positive, 3 is negative. Don't forget that this one way over here is really x plus 1. Remember that? That's my factorization. I broke it down, I factored it. But what are the zeros? Negative 1 is one of them. What does the middle one look equal? What is this x value? What value would x minus 3 give me? 3. So x equals 3, and the last one is x equals negative 4. And that's what you have to do. State all 3 answers. Okay, this problem. 10x to the 4th minus 3x cubed minus 29x squared plus 5x plus 12. Find all zeros. How many will there be? There should be. There should be 4, because the degree is 4. Now, some of these problems, you are going to have to use a quadratic formula for, because it's not going to be factorable, but there's still zeros. So if you get down to a quadratic and you can't factor it, and this part where it's asking for the zeros, you use the quadratic formula. Now, we need to make our list. The list says that I should be finding the factors of 12 over the 10. You guys agree with this? This list is actually going to be fairly large, because 12 has several factors, right? And so does 10. So, again, plus or minus in front of that, it's a fraction. 1, 2, 3, 4, 6, and 12. And 10 is 1, 2, 5, 10. Can you guys agree with this? Okay. That's fairly easy, pretty straightforward. Hey, we found some factors. Here's the problem. You have to divide every one on top by every number in the bottom. So, it becomes plus or minus. All of the ones on top, 1, 2, 3, 4, 6, 12, get divided by 1. When you divide them by 1, they stay nice, right? Everybody understands what I mean by that. But now I have to go back and divide all the ones, 1, 2, 3, 4, 6, 12, and divide them all by 2. But you don't have to repeat. So 1 divided by 2, is 1 divided by 2 or 1/2 part of this group right now? No, it's not there, so I have to put it in. But is 2 divided by 2 there? 2 divided by 2 is 1. I already have 1. What about 3 divided by 2? That's not there. 4 divided by 2? 2. It's already there. 6 divided by 2? Already there. 12 divided by 2? Already there. Not too bad. Now we have to go to 5. Are there any of them divided by 5? 1/5, 2/5, 3/5, 4/5, 6/5, 12/5? There is no of them that are going to be that. So I have to put 1/5, 2/5, 3/5, 4/5, 6/5, 12/5. This list is getting very large, isn't it? Now I have to go back and divide them all by 10. 1/10? Not there. 2/10. 2/10 reduces to 1/5. That's already there. 3/10? Not there. 4/10 is 2/5. We're good. 6/10 is 3/5, we don't need that, and 12/10 reduces to 6/5. So we're actually done. So we have to make a list. Remember, they're all plus or minus. How many choices do we have now? That's a lot of fractions. You guys are going to have to work with fractions. I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, positive, 16, negative, 32 choices. Get synthetic division out and go. Now, we're all going to do this together. We have the answers already, so let's pick one here that does work real quick. 10, negative 3, negative 29, 5, and 12. And we find that negative 3 over 2 works. Negative 1.5. Bring 10 down. Negative 1.5 times 10 is negative 15, which would be a negative 18. 1.5 times a negative 18, it's a positive. What do we get? Divide by 2, multiply by 3, it would be 9 times 3 is 27. That'd be a negative 2 then, which would be a negative 3, which would be, oh, positive. So it would be 8, and 8 times 1.5 is negative 12. Okay? I know I went through that pretty quick, but it comes out still being nice numbers at the end, right? Underneath. We found 1. We have to find 3 more. If I put this back to a polynomial, I will have my what? Leftovers, right? Remainder, no. Constant. X squared, and then x cubed. I can't factor that. Maybe I can if I put that, maybe group it or something. But here's a cool thing. You can continue from the existing numbers in that form. And the next one happens to be 4/5. So you guys would have to go into decimals. 4/5 works. Okay, I'm not going to do this with you. But 4/5 will result in a 0 here. That's 2 of them. You guys know what the quadratic formula is. This gets to a quadratic. That quadratic is not factorable using our techniques that we know. So therefore, we have to use the quadratic formula to find the other 2. So that will give us all 4 answers. So keep going until you get down to a quadratic and then factor it.